going to introduce our next speaker. If you all could come and sit down. Our next speaker is Radu Motisan. He came all the way from Romania. Last year, 2014, he was a finalist or semi-finalist in the Hackaday Prize. This year, he is a finalist, and both of his projects have to do with environmental monitoring, and specifically global networks that communicate about environmental monitoring, which is something we really have a need for in this world. So please welcome Radu.
Test, test. OK. Hi, everyone. My name is Radu Motisan, and one project I want to talk to you about is the Global Environmental Surveillance Network. The interesting part about this project is that global attribute, and I'm going to go into some details later. You'll see what's about. So one thing you don't know about me is that I am a software engineer, so I guess I must be to the wrong conference here. Anyway, the thing is that I like building things, and one of the reasons that I got here and got me into hardware. And yeah, I think there is a lot of potential in the community of makers. There is a lot of creativity that needs to find its way to some final projects and products. Because it's nice to play and do various tests, but it's even nicer when you manage to make something happen, something like a product that is useful to other people, something that has a finality, and it's not just a test on a benchmark, because most of the projects look like this. Lots of wires. I actually was involved into some experiments with high voltage some years ago. And some of my friends used to have their desks looking like that. And yeah, there were a few accidents, like, you know, arcs jumping around, and they didn't know what happened. They just woke up on the floor. But yeah, that was high voltage. So even so, yeah, it's important to try to be more organized. I'm not necessarily talking about keeping your desk clean. Yeah, that's important, but hey, this is just a small detail. It's important to be organized in the fact that you need to structure your ideas. So, OK, you're doing some stuff, you're building some things, but you really need to know what's the plan. So if that doesn't lead to anything, it's somehow wasted time. And unfortunately, we only live for a few years. So yeah, I think it's important. So, as I said, following this path, trying to go from an idea to something that's useful is quite challenging. And most of the people I know stop at the first steps. It's usually curiosity that pushes them to try things. They have these ideas. There was a commercial I've heard. It was about some internet provider. It's back home in Europe, so you probably didn't heard of it. Anyway, the idea was that they were trying to advertise the fact that by getting internet connectivity, we would all get to benefit from it, because there would be more people to participate into projects and to put their creativity to use. So yeah, it's important to use our resources and to put our creativity to something that's actually useful. So for that, we also need to identify a purpose, like, OK, we'd like to play, we like to spread all those wires and see the LEDs blinking and yeah, have fun while doing that. But we need to know why we are doing that. So creativity is something that just shows up. It's in all of us. We need to channel it to something useful. And by doing that, we finally manage to reach a goal. And that means that we manage to do something that is useful, that has a meaning, that usually helps other people. So it's not just us having fun and spreading wires on our desk. Getting back to the project, which is also finalist in the Hackaday Prize, there was a long journey trying to walk this path. And yeah, at the beginning, things looked like this. And there were also prototypes built by hand. And finally, it moved into production. And it looks even better. So yeah, it's possible. And there were very little resources invested in the process. I'm not talking about time. It needed a lot of time. But by resources, I'm talking about things that are accessible to the regular guy. Like, you don't need to own a factory to make a hardware product happen. No, you just need a good motivation, a good plan, and to know your path. So to tell you a few things about the project, I stressed the global attribute at the beginning. A few years ago, I wanted to have a station that does some monitoring. I just hooked up a few sensors and had a case which was rainproof and mounted it outside. And I wanted to see how things change in time. How would, for instance, the rain affect the background radiation levels? Because, you know, there is radon, and rain can wash that. And I was curious to see how the numbers are related and to understand new things from that data. It was quite interesting to have it. Radiation really was constant, but I used it for seeing the temperature outside. It was quite useful to know whether I needed a sweater when going out. Yeah, well, it moved on, and I thought about trying to turn it into a bigger thing, like if it proved useful for me, to try to offer it to others as well. But it wasn't that easy. I had it as an almost working thing with some wires instead. Yeah, it wasn't really the cleanest project. But I had to structure it in a way that could be put into production. So this includes documenting everything, having the circuit planned and tested properly, also building a case, also getting into economical aspects like trying to use fewer components where possible, and identifying better supplies. But eventually it happened. And I'm happy to say that at this time, this project became known worldwide, and it has like a few hundred nodes operating constantly, and it also went into the big data sector because it accumulated a large amount of data, and it's getting interesting not only for the hardware device itself, but also for collecting that data and learning from it and extracting statistics and seeing how the numbers change. And yeah, there is a lot of things to do with data mining, and it's getting quite interesting. And the hardware also evolved. You can see at the top there are a few prototypes which are entirely built by hand. The one to the right, I also did like a few tens of those soldering by hand after I was able to take my hands from the production chain and just focus on developing new models and trying to improve what I have. But as you can see, there is quite a few devices there, and each of them had their own chain of design and production. And this one here is the simplest one to build. You can see it is entirely with through-hole components. So I intended to give something to the maker community in a form which is fun to assemble. This is actually a kit. So it gives a few hours of fun assembling and soldering. And it's really interesting to see that it works and provides data. And also, it sends all data online and can become part of this big system the project is. And all the modules have internet connectivity. These modules here are Ethernet modules, and they can just take an Ethernet cable, and it's like plug and play. You really don't need to know anything about network configuration. If your router with the internet access has DHCP, it will just go online in seconds after acquiring its IP automatically. This year, I had to think to something better, and also complexity raised considerably. And this model here is what is currently running in the Hackaday Prize. I had to somehow continue what I've started previously, because starting too many projects at the same time will lead you to nowhere. So it's important to reach that goal I talked about earlier. So my plan was to try to develop the infrastructure and just come up with better hardware. And that piece of hardware over there is a device that is portable, has a rechargeable battery, has several sensors, and is slowly moving towards better asserting the air quality and the pollution problem. And yeah, it's really interesting, because doing some field tests, I managed to see interesting data correlation in the pollution patterns. The city I come from is nothing to compare to San Francisco, for instance. It has only like 300,000 people in it. But we have our crowded hours and the traffic. And the data shows variations related to those moments. And not only that, I also made some test equipment which used the same infrastructure, but it was designed to be mounted on the outside of a car, and just drove along the city. And I was surprised to see a few points which shown elevated radiation levels. So then I continued and had a trip across the country. I just drove for a few hundred kilometers, and I saw that there were hotspots in radiation, and I'm really concerned about it. My projects are open source, and the data is available for everyone to see. But that part of the data, I think I need to wait a bit until making it public, just because we have some legislation on strategic resources, and I think I run into some areas rich in uranium. So yeah, that might not be a good idea to make public just yet. The idea is that people must become more aware of the environment around them. You know about Fukushima, you know what happened. I'm not sure how many of you followed the news those days and were aware of the fact that some of the numbers were not immediately made public. So it was like some representative from that company that had to deal with the incident, and they come to the press and just offered some very scarce numbers, and the data was somehow covered up. Of course, they were forced eventually to recognize the amplitude of the event, but people really knew very little about it those days. And here on the West Coast, I think it was quite problematic with the wind blowing from that side. And yeah, it is us who get affected. So it's nice to be concerned about making enough sport and eating healthy and things like that, but there is more for us to take into account. And unfortunately, there are several chemical and physical factors which are invisible to our eye, and we need tools for that. And going from that idea to something that can actually be useful to other people, this also comes into the context of this year's Hackaday Prize competition. It was really a very short time to make everything happen, and there were some moments when I almost had to abandon the race. For instance, this is a log. Please excuse any errors in it. It's just a few ideas added in a log just to remember the things that had to be solved and some of the problems I faced. For instance, this thing here, we had to ship 3 beta prototypes for one of the parts of the competition. And that meant that we had to have the hardware ready and partially working. So it wasn't enough to have just an idea and just try to dream of something that could do really interesting stuff. No, we really needed to have the real thing put together, partially working at least. And for me, that meant having 3 units up and running. And the problem was that the LCDs, I had a few, and I was only left with 1 functional LCD left. And I needed 3 units, 3 functional units. So there really was no way around it because I got some of those LCDs from China, and the shipping takes a lot of time. So I was almost out of the race. And the thing is, I found a solution, and the solution involved just dropping some touchscreen driver IC that those LCD use, and just hooked up the touchscreen directly to the microcontroller and interpret that touchscreen data directly in the microcontroller software. There was some XP something IC that normally did that, and I was unable to acquire more in useful time. Then I found some old project which had a compatible LCD, and finally I managed to somehow get the 3 LCDs I needed and hook up everything in useful time and have it ready for shipping. And by have it ready for shipping, just imagine the UPS guy calling me, okay, I'm on my way to get to your location. Do you have everything ready? Do you have the invoice? Do you have the package all packed up and ready to go? Oh, hey, but not yet. Could you just give me some more time? It was like end of his business hours, and I was begging for like half an hour. He said, yeah, okay, I'll just try to get something else. In the meantime, I'll get to your place in half an hour. I said, yeah, okay, if that is the maximum you can give me, fine, be here in half an hour. Then he was just knocking at my door and, okay, is the package ready? And I was like, with the third unit in my hand, uploading the software in the microcontroller. Well, yeah, then just put everything in the bubble wrap and it was ready to go, but it was really in the last minute. So this is just because there were so many challenges. All of the things here were time-consuming issues, really invisible things that, okay, they might be really small for you, like changing a cap or things like that, but wasting time on finding the problems is really a problem. And why I'm saying all these details of the inside of the project development, because when you have a hobby for making things, and you're a maker, and you like to experiment and build things, you do it for fun. But things become more serious, because when you try to push that further and move to producing an actual hardware device, there will be challenges. And if your motivation is not strong enough, there won't be anything fun to push you to move forward. Like, okay, you're having your fun and you just build all those wires and it's all great until something pops up or you have a problem like the high voltage thing or things like that. But you really need more than that to be aware that the process is long and there will be obstacles in order to get to a final result. So yeah, it can be done, but the important ingredient here is the will. You really need a strong will and know what you have to do. But it can be done. So the project at this stage, because I also wanted to give you a few details on what this project is. The project has spread considerably all across the world. What you see here are actual stations. The round icons are single stations, and these here are clusters of units. The bigger the figures, the more units are in one cluster, and the parameter selected is averaged, so you can just see in one glance just what the average is, and there is also a color gradient. And this thing here, I'm not sure what big city is close to this location. I think here's Chicago, and okay, you probably know better. I had to contact that guy and ask him, hey, is everything okay there? Like, do we have a technical problem? Is there a malfunction? Does your unit need to go into support? Do you need to ship it back to me? Oh, he was so calm. He said, oh, no need to send it back. My daughter was doing some experiments for school. I just gave her some depleted uranium. And yeah, well, at some point, I think I'm going to have some problems with the authorities on these kind of matters. So yeah, this is the problem when you are trying to go on the open source road. Everything is visible. So I currently have one of the units with me, and I was lucky. The guys here helped me get a soldering station this morning, so I missed some of the first things in the events because yeah, I had a loose soldering. I discovered that traveling with the airplane also causes a lot of vibrations, and Some equipment can be sensitive to that. Keep that in mind if you design hardware. Also, is part of the stress testing. I didn't do much of that yet for this new unit. The others are fine. Like, there was that list with the several devices. This one here, it has an aluminum enclosure, so is rugged and can be also mounted outdoors. It can withstand rain if mounted in vertical position, so the connectors need to be facing down. Also, the new one is also aluminum. And yeah, you can see real-time data from the unit I have here. You'll be able to see it close in the QA section later if interested. It currently measures the air quality and some various other parameters related to air. And there also is alpha, beta, and gamma radiation. It has an LND 712 Geiger tube, manufactured here in the USA. It's quite a good one. And I was lucky that I was inspired and had a small modification in my source code. Just before I left, I set a variable to false, and that had as an effect that the sounds were turned off. I just set it to mute by default, and that was a good idea because on the airplane, I took it off my baggage and turned it on, and it went like woo, woo, berserk, and luckily the alarm was turned off. It was the radiation. You know, it's the cosmic rays. You get bombarded when traveling by airplane. It's like 20 times what we get here from natural sources. So yeah, that was a good move because it already looks very suspicious. I always have problems traveling with these things at the security, like those nice old ladies employed there taking it out of your bag, making you explain what it is. And there was one which could be opened, and the sensitive Geiger counter was exposed, and that lady was like trying to put the finger on it to see what it is, if it's a bomb or not. Yeah, I was like, hey, stop, please, don't touch that. It's sensitive. She was suspicious. Why? Do you have something to hide? No, but please, don't break it. I need it for a presentation. OK. So yeah, building hardware is really nice. As a software developer, for me, it was really exciting. It can be done. Do it. Creativity needs to be channeled. There are so many things we can build. The technology is all around us. We have the tools that we didn't have years ago. It can be done. Please do it. It's for the benefit of us all. Thank you.
Hello. Radu will be in the Q&A area like everybody else, which is over there by the whiteboard.